Hey, what's up, Ziguanas? This is day 13 of the 30 Days of Z Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language, Zig. My name is Dusan. Welcome to Zignited. So today it's day 13 and it's Friday, so it's kind of Friday the 13th. Hopefully unions will not be unlucky for me today, because they're on the menu. So let's see what they say about unions in the docs. A bare union defines a set of possible types that a value can be as a list of fields. Okay. Only one field can be active at a time. The in-memory representation of bare unions is not guaranteed. The in-memory representation is not guaranteed. What they want to say by that? Bare unions cannot be used to reinterpret memory. For that use PTR cast or use an external union or a package union, which have guaranteed in-memory layout. Aha! They speak about the layout here. Okay. Accessing the non-active field is safety checked illegal behavior. Aha! Okay, so they can have only one field active at a time, and if you try to access the different one, it will be illegal behavior, which makes sense. Okay, let's play with them. Let's take this one here, and yes, I have to prepare this a little bit. So I want this to be called print, and I want to do this here. I don't need this, I don't need this, and let's just test if hello world will run. Yeah, okay. So now let's see what they want to test. They create a variable and then they do something with it. Let's try to do that here. And let's first see what is it about. So payload is a union, which visually looks very much like a struct or enum, not more like a struct, let's say. Then what they try to do here, and of course in this case we have 3 types that are specified, and I guess this is just like the name, because this is the reserved keyword for the type, so it's I and the number. So this, I don't believe it's reserved the int like some other languages, so that's why they can use it here as a name of the field. So we have 3 types, different types, and then what they do, they create one variable and they use this union, and they say, so this is something that I've seen with struct, so this dot notation that they use without saying payload.int, but just .int, which is kind of cool, shortens the things, and then they set the value to it. So basically, if I understood correctly, they activate this type and they assign to this union this number, and then they change the type, switch the type, let's say, to a float, and then they do this. And let's print it out. So let's print the payload just to see how it will look like. I'll try to say n here. See how this will work. Aha, this is what they say. This is how they activate. They try to assign assign here a float into another one. So how do you activate a different one? So I guess they will show that. Okay, this is basically the same error that I got. Yeah. You can activate, this is what I wanted to see, how they do it. You can activate another field by assigning the entire union. So this looks the same. Let's see what they do. So this is the same like in the previous example. Then here they just test it. Aha, they just like do this thing again without using var in front. Okay. So let's comment this out and let's say this here, this will break because the int is activated. So if I just want to see it before I change into float. Okay, now it's never mutated. So let's do for now, let's do something like this, if I remember correctly, just to dump a load. Yeah. Okay, so it's just like showing the memory, probably because I have any. And if I do this, will I get a value? No, still kind of looks like a pointer because it displays the memory address. And if I try to do will it break? I have to cast. Yeah. Okay, so then let's see if I do the next thing. So then I don't need this. I think actually I cannot have it. It will break the code. Now that I change it, so I change it to float 1, 2, 3, 4, and let's print it again, which in this case doesn't make sense to print if I cannot see the value there. I guess they will show how I can access the value itself. Yeah, now it's just like the same memory address, nothing different that you can say, that you can see right away. Let's just make it a bit easier to read. Yeah, white. My mistake. I left this here from the previous example. Okay, yeah, so definitely the same address. And what is this at the end? Okay. So let's delete these. Sometimes I don't see anything, like I completely oversee some details. Yeah, okay, now it makes more sense. Okay, so this is the... okay, because I print the entire payload, so if I just access the field, it will show the value of it. So let's do that. So let's do here the payload and then the payload int. And more importantly here. And let's run this one first. Okay, 1, 3, 4. Yeah, so let me try to do this here after I activate this one. So I guess this will cause an error because I activated the float part of the union. No, it works. No, it breaks. Okay. Okay, yeah, this makes sense. So this was what I was expecting. And then because I didn't scroll, I thought it actually worked for some reason, but this is more aligned to what they said at the beginning. It makes more sense. Okay, cool. So this is kind of like their version of generic, but I think I've seen something that is literally generic before somewhere. So I'm not sure if Zig has something like generics or not, or just something that look like a generic. But anyways, this is kind of like similar thing. Unions. Okay. And then let's see the next example. Tagged union. Unions can be declared. They miss something. No. This is the next thing. They just say to in order to use switch, so I will skip this part because I haven't touched switch yet. Maybe I will, let's see. So no, I don't think I will make it today up to switch unless this is very short. So I will skip for now. To initialize union when the tag is comptime known, see union init built-in function. So first of all, let's see the tagged unions here, and then maybe go back. Tagged unions can be declared with an enum tag type. This turns the union into tagged union, which makes it eligible to use with switch. Aha, so they cannot be used without this declaring the tag type. Okay. Tagged unions coerce to their tag type. Okay, so let's see what they want to do. Okay, this is the enum. Let it be here. And let's do also this part. And then let's actually do copy paste this entire thing, and I will play. And let me comment this part. Okay, C is complex type. Okay, equals 42. Let's see first. The complex type is this one, the second one. Okay, the difference here, this one is not tagged, and this one, no, this one is enum. Yeah, so it's not union at all. But this one is a tagged union, but they use this type. Okay, nice. So they're not using some built-in type. They are using the one that is created here as the enum. Okay, and this one just has okay, not okay. So then they use this to tag this union, and then they create the same named fields. And this time they say okay is U8 and not okay is void, which is interesting. Then let's see what they do. So const C equals complex type. So the second one, which is depending on this one, and they say they want to set OK to 42. So they're targeting this one. Okay. Then they coerce or cast this as a complex type tag, which is this one. So they use the C to convert it to this type, and then they ask if it's actually this thing. Okay, so like always, I'm going to print instead of trying things. And let's say here, this will go here, and I will also do it here. And this is the expectation, right? So I'll copy paste as a comment just to see, and then let's not switch. Yeah, I will not switch at all because I haven't touched switch yet. Let's just do this part. Yeah, so we get this same type, except that they say play dot in front. So I think I've seen this play dot notation before in some different example. So probably some struct in the background that runs, or name of the thread or something. I don't know yet what it is, because we don't call anything here play, so it is a built-in thing. Okay, so let me just double check one more time. So first they do this, and they are taking this field and setting the value of it. I mean, they are selecting it, let's say, this union type. They are activating, I think is the official word, this field with 42, which is a comptime integer, right? But they are then making this literal and U8 here. Then they are converting it, and they use the entire union. That's interesting. So they didn't say complex type. Oh, yeah. So C was it the same? Here the entire union? I think yes. Payload equals, yeah. So I did the same thing with the payload before. So this is the entire union, not the. So here when I printed the payload, it showed me this like a pointer, like the address. So it didn't show me the value. And then when I did int notation, I reached into the field here to get the actual value. So basically here they have the entire thing. So they're not trying to convert just like the field that is active, but the entire union into this. Probably they have to do it because here they tag it as this type, the entire union. So they're not tagging the field, but the entire union. So probably that's the reason. Or doing it in this way instead. So I was thinking maybe they would do it like C dot and then the field to convert it to. Oh, no, this is complex type. This is the other one. Yeah, actually, yeah. So what I said, but they're converting the entire union to this enum, not just the field, which makes sense basically. Yeah, okay. So this is, well, it will take some time for me to get used to it, but it's logical. And then they try to switch. I will skip that part. Then the next thing, what they want to do, get tag type. Okay. So they get that from std meta. So I will have to import std like this, because, or just go to dot notation, use the dot notation until I reach this thing, but I will do it in their way just to speed up things. And let's see if the type will be the complex type tag. So if I print here, so I want quotes here, type, let's see, like this. Yeah, so in this case, again, it's just like this prefix play and then complex type. Yeah, so this is the expected type. Okay, in order to modify the payload of a tagged union in switch expression, so we'll skip. Unions can be made to infer the enum tag type further. Unions can have methods just like structs and enums. Okay, let's see this one. This is one huge enum, union, not enum. So let's copy paste here and let's comment things. Let me see what they do. So this is a union which has one field that is integer called int, which is integer 32. Then the other one that is boolean called boolean, that is boolean. Void can be omitted when inferring enum tag type. So they just say enum here, but they're not specifying any specific one. So basically it will be a void, right? Void enum, if I understood correctly. Yeah, this is the thing when you read the docs, so they kind of like skip some details. They don't explain all the details running under the hood, so I have to play. Okay, so let's assume, I will assume it's like this. I'm not saying that I'm right, but for now I'm going to assume that this is basically defining it as a void enum. No, actually they are commenting it out here, none. Okay, they are actually commenting this line here. So they are omitting here. So they're basically doing this void, but they are omitting it here when inferring an enum tag type. So they are inferring from here that this will be the none field, which will be of void type of this enum, so if I understood correctly. Okay. Then they have this function declared, basically as the fourth thing here, fourth field. They call it truthy. Takes one argument called variant, which is this type right here. They call this union of variant. So that's why they call it self. It returns boolean, and then they use switch. I didn't see this right away, so I will not play with it because it's a switch. So yeah, can not play with this yet. Let's see the next one. Tag name can be used to return comptime. This is slice, right? Or array that is terminated with 0. I keep forgetting, so I have to practice. I will practice offline a bit these things that I've went so far, because I will not remember them if I don't play with them, and I don't want to bore you guys and repeat the things that I already did, unless it's some kind of project or something. Value, comptime value of this type, pressing the field name. So it can return a comptype array or slice. I forgot what is it. Value representing the field name. Okay. So let's see what they do. Let's first take this part here, and I can delete all these things. There are too many things happening. I'll just leave one print so that I can copy paste easily. Then I have to type. So it's a union. That is an enum type here. So 3 fields, 3 different types: ABC, integer 32 bool, or U8. Then what they do, they try to see if this equals A. Okay, so let's actually use this tag name built in a different way. I will just print it. And yeah, this is the type of this. So basically this is a string which they, under the hood, they use the type of array, if I'm not mistaken, not a slice, but array. Okay. So let's run this code. tag name small 2 a. Okay, and let's see. I'll just say the same thing here. Basically, I'll just, and let's see what will happen if this will break. Yeah, because of this formatter. So let's do S, because it should be a as a string. What they are expecting is a as a string. Yeah, so it is this what they expect here. And just to double check one more time, if I do it with any instead of S, so then I should get an array, and it will contain the numerical representation of this character, and it's the only one, so it will be just like one number. Yeah, 97, which is Unicode code for A, character A, lowercase. Okay. So if I called it, for example, AB, then it would be AB and 97, 98, right? Ah, okay, yes, of course, if I don't have A, I have to change this, and then in this case it will be AB as well. Yeah, AB 97, 98 is an array. Okay. Extern union has a memory layout guaranteed to be compatible with target CABI. Okay, packed union has a well-defined in-memory layout and is eligible to be packed in a packed struct. Anonymous union literals. Anonymous struct literals syntax can be used to initialize unions without specifying the type. Okay, anonymous struct literals. So let's see. And first, yeah, they don't use switch, nothing like that. So let's do this. So a number, which is a union of int and float, I32, F64. And then they test it here. Let's see what they do. So they create one constant, call it I. It's a number union. And here they use, so this is the anonymous struct that they mentioned, right? Anonymous struct literals, okay. Without specifying the type. Okay, because before, I just want to compare it with previous example here. When they created, so this is how they used, I'm going to copy paste just to compare the declaration, right? It's complex type, and that's a union, yeah. Just to double check. So just to compare it. So yeah, of course, here they are saying the type is number like this explicitly, but they are here using the anonymous type on the anonymous struct on the right side, and here they're actually using the complex type. And will this work? So I'll comment out this just to have it as a reference, and let's see what is this make number. They refer to some function. Where is this coming from? I don't know what this is. It doesn't look like a built. Ah, okay. I was about to say it doesn't look like a built-in function because it doesn't begin with at character with the monkey. But now it makes more sense. So let's actually go step by step. So I will comment out these 3 lines here. I'll put this one above that I don't confuse that this is the part of the current code. So once I create a constant, I just want to print it out, and I deleted the print, so let me type it. So it will be I equals something, and let's do any here, and I just want to do I here inside, nothing special, just to see if this works. Yeah, and if I say I dot int, should be 42, right? Yeah. Okay. That makes sense. And I just wanted to test something before I actually use the function they made. I wanted to do it in this way. Can I just depend on a compiler that it will understand that this should be, because I don't think so, because I don't mention a type at all. So it shouldn't be. It shouldn't work. Oh, it does. How can it know? How can it know that I want to use this number? I don't mention it anywhere, but it's very cool that it does. What if I had 2 unions which are the same? What would happen now? It still takes one of them. How can it know? How it decides which one of these 2 unions is the active one? Okay, so there is something in the background that happens, and it's very interesting what happens. But I will not spend any more time on this now because I want to finish the other things. But it's very interesting. Okay, so let me delete this one here. And now let's play with the function. Const f equals make number, and let me return it how it was, just to be sure that I avoid some problems that might happen because of what I just did, so that we're on the same page. Like ducks and I. Okay, let's see what they do now. They want to set the value to this constant, to whatever this make number returns. And let me see what the function does. It returns a number union, and it creates, so they also do this. But okay, here I understand why, because they say this is the type, and then they use the anonymous struct. But here I didn't understand. How can it understand which one of the unions I want to use? Okay, this is more clear. So basically it will return the union, and it will activate the float type, and it will be float. So then if we print, let's do here, so the I is activated with integer, so this should be 42. I actually printed already here, so I don't have to do this one. I will just do the f float part here, which should be 12.34. Yeah, 120.23. 234 times 10 to the power of 1, so times 10, basically. Okay, that makes sense, because then it will be 12 if you multiply by 10. Let's see. Yeah, this is it for this part. Opaque declares a new type with an unknown but not zero size and alignment. Okay, this is not union anymore. Okay, doesn't matter. Let's see what they say. So, declares a new type with an unknown but non-zero size and alignment. Okay. So there is something there, it's not zero size. It can contain declarations the same as structs, units, and enums. Okay, this is typically used for type safety when integrated with C code that does not expose struct details. Example, let's see what they do here. So they create derp and wet, however you pronounce this. There's two new types with unknown size, but not zero. Then they create the extra function. So I haven't touched extra functions yet. So I think I will skip this part. Yeah, so a lot of things happening here that I haven't touched. So let's go to the next one. Blocks and shading. Okay, so this is something we can do now. So I guess I finished with unions. I didn't research this spect union and extern union. So I went with the basics, which is basically what I want to do now. Because I'm trying to cover like as much as I can of these things. So go wide first, but a little bit shallow, so that I have a general idea of how it works. And then later, once I go through all this, so it's not that far, I think, until we reach the end. So I definitely think I can make it in these 30 days to go through the entire documentation, at least on this like more shallow level, and then go from there deeper. Okay, blocks are used to limit the scope of variable declaration. So pretty standard thing in programming languages. Let's see if there is something that is special to Zig. Let's do this. Oh, I don't want to do it actually there. I want to do it in here. I will leave one print just to copy paste things. Let's see what happens here. So they declare the block inside of the file. In this case, I declare it in main, which then inside has one variable called x, which is i32 set to 1. They dumped it here and they try to access here, which I guess it will break because it's out of the, it's not in the same scope. So let's just move this here. I literally realized that I copy pasted a single character. Okay. Yeah, undeclared x. So this will not work here, but of course, if I do it here, should work normally. And it's a number. It doesn't have to be any, but doesn't matter. Where? Why? Ah, here. Okay, okay, okay. I forgot to comment that part out. Yeah, this is as expected. Okay. Blocks are expressions. When labeled, break can be used to return a value from the block. Ah, yeah, remember this when we played with while loop. So it was a little bit different I think because I managed to I think I managed to return even anonymous block that was the part of the while loop. I think maybe I'm wrong. Maybe I don't remember correctly, but I think I did that. And I also played with some labels with while. I remember that. Okay, let's see their example. And let's leave this print. And let's see. Y is set to integer 32, 1 to 3. Then const x is el key, which is a block label for this block, in which they increment the y by 1, which should be okay because the inner block should see the outer value normally. Then here breaks out of this specific block because they're theoretical, they could be nested and it could just like get out one level, not from the full nested structure. And then it returns y. So this should become y, which basically means 1 to 4, right? Because it's y plus 1. So then they try to see if both x and y will be 1 to 4, which basically means that this is not shadowing this variable here. And it makes sense because we don't have var in front of it. So it will just like access directly this outer scope y, and basically it's the same. Okay, so let's print and see how this looks like here. So I'll print both x and y. This time I will not copy paste a single character. Let's see. Yeah, 1 to 4, 1 to 4. And I want this to be, now I will copy paste 2 characters. That's too much to type. 1 to 4, 1 to 4 like expected. So nothing weird. Okay, then let's see what else they say about blocks. Here BL key can be any name. Yeah, so I guess like the same rules apply as for the variable name or constant name. So probably it cannot start with the number, it can contain underscores, case sensitive and so on, like standard. Yeah, I haven't played with those. I will maybe some other day. Shadowing. Okay, this is about shadowing. What I mentioned a few minutes ago. Let's see how they do shadowing in Zig. Identifiers are never allowed to hide another identifiers by using the same name. So this will break the code. So you cannot shadow. Okay. Got it. Let's do it here. And I will not test. I will just create an anonymous block. It's okay. So just to double check, pi. So this even doesn't need to work because it should break here, right? So because they define here pi, which is constant here, and then they go basically in this case 2 blocks inside, but it will be the same with 1. And they try to redeclare the same, let's say, identifier, because here it was const and here it's var. So I was about to say the same variable, but here it was not a variable. So let's say identifier. And this should fail, right? Because the shadowing is not allowed, obviously, if they say so. Yeah, shadows local constant from outer scope, okay. And I guess it will be the same if I just do it one step closer, one level more shallow. shallower. Can I say like shallower? Yeah, the same thing. Okay, so no shadowing in Zig looks like. Because of this, I like shadowing in Rust, how it works in Rust. I don't like it, for example, in Python. In Python I actually don't like this global keyword when they use it. Anyways, let's go back to Zig. Because of this, when you read Zig code, you can always rely on an identifier to consistently mean the same thing within the scope it is defined. Know that you can, however, use the same name in the scopes that are separate. If the scopes are separate, yeah. So they're now siblings, right? So sibling blogs, they're not in like an ancestor descendant relationship, but they are siblings. So they should be fine. Let's test that. It's not that I don't trust the docs, but just to see it myself. And here, I don't even need to print. This is just like to see that this will compile, that it will not break. Yeah, so it doesn't break. So here they use pi, here they use pi, here it's a const, here it's a variable, sibling blocks, they dump both times to avoid the compiling error. Okay, even different types, yeah, they're not related, so basically no problems there. Empty blocks. An empty block is equivalent to void. So they here literally, so let's do this. Oops. Okay, A is the empty literal block, and here they have this void prefix. So it's not a label. What is this exactly? They don't explain what this is. This is a type, I guess. Because not labeled, there are no colons here. It's not a function, so it's not that they're running something and then getting this. So I guess it's like a type. An empty void. They don't say, they just say equals to this. They don't say what it is. Guess it's a type. Okay, maybe I'm wrong. Let's see. So they have that one, and they ask if it's void. So if this is a type, it equals in Zig to this type, which is void without curly braces. Okay, let's print them. Let's print all these, and I will add one more line to print the equality part. So first, let's print the type of A here, then type of B, and then finally if they're equal. Expect, okay. Of course, I want to delete this. Okay, void, yeah, makes sense. Okay, just one thing, so I guess, they do import, because I got this error, like, that they didn't recognize the expect as an identifier. I just wanted to see how they import it. So it's from std testing. I'm not going to test yet, but I'm just wanted to see how they import. Just to see, because I didn't pay, I haven't been paying attention so far, because I didn't want to do tests yet. Okay. So now we have switch, which I think I'm not going to start now, because it looks it's going to be a bigger topic. Let's see if there is something short that we can do now. Switch while I did while for if with optionals, defer, unreachable, no return functions. No, I think these are all optionals are here. What they say here, if with optionals. Let's see optionals, if it's a huge section or no. Okay, this is all part of optionals. Null, optional pointers, optional type. Let's see if I can at least do the first part. So I wouldn't like to start this if I'm not going to spend the next. It looks like I will have to spend 40 minutes or more. Let's see if there is something that is short. Okay, here is a void, the thing that I touched a few minutes ago. So we can do this, and it looks like this void is, yeah, here, the part of 0-bit types. So let's do these 0-bit types if they're not long. Uh-oh. Oh, okay, let's see. They don't look so complicated. Maybe I can do these 0-bit types. Okay, for some types, at size of built-in will return 0. This is the first one. Then the integers of u0 and i0. Aha, the type. I didn't even know that you can set the size of integer to be like 0 bits long. Why would you do that? Probably there is a reason. Arrays and vectors with length 0 are also size of 0, or with an element type that is a 0-bit type. So basically, if they have this type, that's interesting. And enum with only one tag, it will be, size will be 0. I would have expected that this is 1. Why this is size? One tag, not one field. Okay. That's a different thing. Struct with all fields being 0-bit types. Okay. Union with only one field, which is a 0-bit type. Okay. So there is a difference. A struct, if they have all fields 0-bit types, and the union that has only one field, so it cannot have multiple types. So even if you have, can you actually theoretically have two fields which are 0-bit type? So I think yes. If you have, let's say, one is u8 and one is i0, but then it will not be size 0. Okay, that's interesting. Yeah, a lot of these things are kind of like very weird if you think about them for the first time, but of course I don't think they are crazy, like that they designed this just like that. So there has to be a reason. If you dig deeper, it would be probably very interesting to see why and how this is used in the real light, in the real world. These types can only ever have one possible value and thus require 0 bits to represent. Yeah, this is probably optimization thing that they've done, because I guess if you want to use Zig to do some embedded programming or alike, you want to save every single bit possible. Code, okay, that makes use of these types is not included in the final generated code. So they will completely optimize during the compilation time. Okay. Okay, let's see. 0-bit types. Let's just do, what is this? It's creating a void. So this is a function called entry. that's returning void and has these 4 lines. So they say x is void, y is void, x equals y equals x, and it doesn't return anything. So basically this is everything is void here. Okay. So let me just do not a function, but let's do this. I just want to test these things and play with them just a bit to see how this will work. So they set both x and y to void. Then if they change x to y, basically it's the same thing. They change y to x. So let's just play. Let's just print here the x and the y. I mean, I know what it's going to be, but it's a test of voidness. Yeah, surprise, surprise. Okay, when this turns into machine code, there is no code. Oh, some assembly here. There is no code generated in the body of entry. Aha, okay, they are now specifically speaking about this entry function. There is no code generated in the body of entry, so it's an empty function. Even in debug mode, for example, okay, this is the architecture, 64-bit. Then they have, yes, it's been a while since I've been doing this. So push, move, and pop. So this is, I believe, to push something to the memory. Move RBP to the RSP. Then pop on the memory, then return X. Yeah, so it's been a while since I've touched any assembly. And I think I never did this one. I did some ARM processors back in days when I was studying. So one for sure was ARM assembly. Doesn't matter. So I will not spend time on this assembly part. Trying to understand, because it's not Zig basically. It is okay, it is related to what will happen, but it's enough that I understand that this will happen at this point. So when they compile it, they will generate no code in the body of the entry. So I guess this is like a call stack, so that you push the things that are, it doesn't matter, I will not spend time. Okay, so they will not generate, if you have void, everything is void in this function, no code will be generated. That's enough for now. These assembly instructions do not have any code associated with the void values. They only perform the function call, prologue, and epilogue. Yeah, so that's cool. Void can be useful for instantiating generic types. For example, given a map if value, one can pass void. So I did not touch maps yet. I will skip this part for now. Know that this is different from using a dummy value for the hash map. Okay, so who is the function? Okay, they use just like, I want to see if they're going to refer to these maps here, but they will not. So let's see what they do here. So this is, I guess, about this part here. I will not read it. I will start from here. Void is distinct from any opaque void. Dot void. No, wait, this is end of the sentence. Void is distinct from any opaque. Void has a known size of 0 bytes, and any opaque has an unknown but non-zero size. Okay, I kind of understand, but we will play with this in the future. because this is known size of 0 and has unknown but non-zero. So that's why they are different, because for sure this is not 0. That's the point. Expressions of type void are the only ones whose value can be ignored. For example, ignoring a non-void expression is a compile error. Let's see what happens here. So they define function foo, which should return I32. And then here they do return. So they call, but they just don't do anything with the value. So then I guess I also cannot do something like this. I cannot just say 32 like this. So this is basically the same thing. A literal. Actually, it's not. It's a literal. Maybe this will. Yeah, it is the same. So it's a different type, but the same mechanism applies. So it is ignored. So I have to do something. I cannot just put a value without the context. So I cannot just put it there, not assign it to something or use it in expression and do something. Okay, so basically then I understand this will run in the same way. But let's do, sorry, here. Let's do the same thing. So now it's just going to be this different type that is ignored. So it will be I32, right? That's what we return from the foo. Yeah, I32. Okay. However, if the expression has type void, there will be no error. Expression results can be explicitly ignored by assigning them to underscore. Okay, let's see what they do. So two functions, one that returns void, the other one that returns the other one is the same we had before. So we'll just add this one. And then when they test, this is fine, this has to be dumped. Okay. So this is for the foo and this is for returns void. So now this should compile. Okay, yep, it compiles. And this is, I guess, why this runs the main, because it doesn't return. It returns void. So it does return something that should be dumped. Okay, I think this is the next topic. Yeah, so we finished with 0-bit type. So I kind of skipped this part here. Not kinda, but I skipped it because I haven't touched hash maps. So this is something that I will do not next time, but in the future. So let me see what I will do tomorrow. What is the plan for tomorrow? I guess switch, right? Yeah, switch is next on the menu because I remember it was used many different times on different occasions here in all these things that I've touched so far. And I also didn't touch this one, the opaque and any opaque, so they are related. I just mentioned them. But yeah, definitely for tomorrow the plan is to do switch, and then I will see from there how much time I will have. Maybe I will move on to something else as well, but I will try at least to do the switch, this entire section, if it's possible, and that it doesn't take more than, let's say, 1 hour and a few minutes. Okay, thank you guys for being here today, and I will see you tomorrow. Bye bye.